back to an episode of the Open Source Cafe. Today we have Francesco joining us from Aiven, and we're going to talk about something very important, data. So some of the questions you need to ask yourself for your data when you're picking the right tools, and what suits best your needs, and how do you actually approach this question. But before we get started, Francesco, would you like to give yourself a quick intro, tell our audience a bit more about yourself and what you do?
Yeah, absolutely. Thanks, Kunal. I'm Francesco. I'm staff developer advocate at Aiven, and I'm a big fan of data and technology. My motto in life is basically use technology to solve data problems. And this is why I find the topic of selecting the proper data technology to solve a problem a lot fascinating.
Amazing. And we have the 5 questions from you here. So can you quickly just share what the first question is, and then I'll have maybe some questions on that.
I believe every kind of data problem starts with possibly the question is, what kind of shape do you have about your data? What is the shape that the data that you have is at the moment that you receive it? Or can you shape the data as you wish before or when you start producing it?
Can you maybe, so you mentioned shape of data. Can you maybe share a bit more about like how do you define the shape of the data, and why are you putting it at, like, as the first question, like why is it so important to understand? And maybe you can give an example, and their implications in the tool selection process, because you're mentioning like, okay, this is the first question you need to ask yourself when you're picking the right tool for your data. So what is the shape of data? Why is it important to understand? And what is the implication when selecting the tool?
Yep, absolutely. So the shape of the data has been a critical part of the data thinking for a long time. If you, like me, have quite some experience in the data world, until some time ago, I would say 99% of the tools that could host data, they were hosting data in some sort of what was called structured form. So you had well-defined columns for the ID of a product, for the name of the product, for the category of the product, for the price of the product. But this, despite is the reality for like a lot of use cases, is not always the use case. Sometimes the data that you produce or you receive, it doesn't have a fixed shape, or maybe the shape is changing depending on the product that you are trying to push to a specific data storage system, or on the type of producers that you are trying to push to use to produce the data. Sorry. The other part is not only how the data looks, but also how you, for example, want to encode the data. For example, we have JSON, which is, one of the most used data types, and certain technology can work natively with JSON. Certain other technologies, you will need to do a couple of tricks in order to get there. Even more, if we go to if we follow this kind of route of how you basically write the data on disk, it's not only JSON or something more structured. If, for example, you take CSV, that is a lot structured, but is it the best way of storing the data? Maybe yes, maybe not. And if there are tools that help you not only storing the data, but while you're storing, validating that the data is in the correct shape, that can give you an extra spin in order to avoid inserting into a data store some information that are, for example, not correct or not in line with your definition. So the first question that I always have is, what is the data that I'm expecting to store looking like? What is its shape? Is it always conform to a certain set of rules, or is it maybe always different or slightly different every time? Depending on kind of this choice, I can already start identifying which are technologies that expect a rigid definition of the data structure compared to other solutions for which each event, each message that you want to store, it's kind of just a document, so it can take any shape.
Amazing. Well, thanks a lot for sharing, Francesco. And if you move forward, you also mentioned, you know, like how does the role of the usage of data play? So what sort of like data usage you have that is impacting the choice of your data tools, and because that's what we're talking about here, right? So you have your data, and the storage part is fine, but also how you're using it, how you're utilizing it. So does that use actually also affect the choice of tools that you have?
Yeah, I believe absolutely. So the first part was dedicated to the shape of that itself. But immediately after, or maybe it's at the same kind of importance level, you need also to define how you will access and reuse the data that you're pushing to a data store. Let me make a couple of examples. I've been for 15 years in the what was called at the time business intelligence world or analytics world, how is it called nowadays. My mission at the time was to create dashboards. Dashboards were a visualization tool on top of usually a database. Why this was a great combo? Because we were populating the dashboard every time a user was accessing them. So every time a user was accessing the dashboard, we were fetching the data from the database and displaying all the visualization. This is one way of interacting with data, which is called like not batch approach, but pool based. Every time I need the information, I want to query the database myself at this point of time. A complete different scenario is, for example, when I want to be notified about something happening. In that case, maybe I'm not looking for a pooling method, but I'm looking for a method or a set of technologies that allow the event or something that is happening in my reality to be pushed to my mobile phone, for example. And again, this kind of access pattern, how you want to reuse the data, which tools you will use in order to access the data, have an impact on the selection of the technology or the set of technologies that you will use to store the data itself.
Thanks for sharing, Francisco. And do you think there are like any specific tools that excel in like certain types of data usage scenarios?
So I believe that for if you think about the usage of data, I would categorize the tools into kind of two different scenarios. On one side, we have this kind of pool-based approach, and it's typical from databases. In the databases, you write the data, and at a certain point, when you want to analyze, when you want to extract, you want yourself to run the query. Think about a website that needs to retrieve the user data or the recent orders data. This is a typical pool-based scenario, and the database, it being relational or not relational, SQL or no SQL, is the perfect fit because they allow to query the database whenever you want. On the other side, streaming technologies like Apache Kafka and Apache Flink are perfect when we need to basically convey a continuous flow of data, when we need to this kind of streaming real-time passage of information. In these scenarios, where, for example, I want to receive a notification where the driver taking the pizza to my house is near my house, I would use a method like Kafka that allows me to receive the order immediately, not wait for a query every 5 minutes, but having in near real time a feed of the events.
That's interesting. And you mentioned about the push and pull approach. So is there like, I know many monitoring tools have this approach. So is there like a benefit over one over the other, like push or pull, or does it
Uh,
depend?
I believe, like in my approach, is again depending on what you want to do with the data and where you want the responsibility to be as well. So, um, let's say about the notification pattern. I don't want to put any logic in my mobile device to fetch the location periodically. I want just the notification to fly when it's ready. So I might want to take the responsibility in the source technology to be able to stream that event as soon as it's relevant. On the other side, with other technologies where you need to provide the data at a specific point in time that is relevant for the user. Let's go back to the dashboarding point of view. there is no need to push the data. I want to visualize the data only at this point of time. For monitoring purposes, that's an interesting topic. I believe the benefit of having the source system to push the information is that you get a continuous flow of information. It's not one query at a time, but you have the drawback of adding a little bit of complexity on the source system to be able to push that information. While on the other side, query-based pattern, have this are pushing this capability, this ownership on the receiving side. So I would say there is no one solution best compared to the other overall. It's always in the little details about how your application, how your system needs to work, and what are your user expectations, and also what are the restrictions of your tools and the ability of reshaping how a certain tool works or how a certain server works for what we were saying about this kind of observability patterns.
Yeah, because I was contributing this tool and they use like a mix of both, you know. But yeah, cool. All right. One thing that is on everyone's mind when we talk about data is security, privacy, and all sorts of things around that. So I'm pretty sure that's like one of the 5 questions.
Yeah, absolutely. So I've been helping in my previous years before joining Aiven a lot of companies, small and big, to build huge data pipelines. And I've never done a project where there wasn't a question about security. And if you are, for example, in Europe now, since few years, we have this set of regulations regarding GDPR, which basically says that each company should be able to demonstrate how the data of their clients is used, changed, and who can see what and who can do what with their data. And eventually, we should be able to ask to remove our data from the entire assets of the company. So the security part is really crucial, not only to be able to say, I want to protect this data behind a username and a password, but even more in this period of time where we are adding new technologies, we are reshaping continuously the data, we need to be able to define security boundaries within all the technologies that we are using to store, to retrieve, to change the shape of the data, and being able to also to tell people what are the steps that their data is going through in our processing and who is responsible of those steps. So depending on the needs of your security system, you will find that some technologies can fulfill all the needs. Some other technologies might have limits. I want to give an example which is really common. Let's say that we have an application that is storing data from a website selling, let's say, shoes. And we have one big table, which contains all the orders of shoes. But then we have what we called regional analysts. So we have an analyst in Italy, an analyst in London, an analyst in India, an analyst in Sydney, and an analyst in the US. In a lot of huge companies, regional analysts should be only able to check the data regarding their region. It's not that the analyst in Milan will be able to see the sales of the shoes in the US. In order to do this, for example, some databases offer what is called kind of automatic row filtering. So you enter the database with the credential of the regional manager of Milan, and by default, all the queries that this person will issue to the database will have an additional workload that will filter all the data for Milan. This is a quite typical, but it's a quite typical use case, but I wouldn't say that is achievable easily across all the technologies. So depending again on your security requirements, you will find that certain technology give you a feature out of the box that allow this kind of setting up the security boundaries. In some other tools, you will either need to create your own version of the tool, create a sort of customized function to do that, or it will be really hard. So again, it's a mix of defining what is the shape of the data, what is the usage of the data, and what is kind of the security boundaries that you need to create around the data that will allow you to select the best platform for your needs.
When you talk about data, you mentioned like, okay, how do you handle sensitive data? And it's pretty self-explanatory why data security is important. So like we don't have to talk too much about that. But when we talk about sensitive data, maybe can you elaborate on what constitutes sensitive data, and what are some of the considerations that organizations should make when they're choosing the tools to handle the sensitive data? But actually, what constitutes is the first question.
Yep. So what is sensitive data? Sensitive data, in my opinion, is anything that you wouldn't like to see stored in a public domain, or anything about you that you wouldn't like to see visualized in a public forum. So, for example, I don't know, the data of where I live, the details of my credit card, my date of birth, it's all sensitive data. But you could, for example, take this to the extra step. So I might use a certain travel provider that books all the trips for me. I wouldn't like that a business analyst in my travel provider. I wouldn't like if the business analyst in my travel provider could be able to identify all the trips associated with Francesco Tisiot. What I would really like is that, yes, they will have the Francesco Tisiot information sitting somewhere in the database, but when the analyst tries to access all the trip details, all they can find is a generic QID. So they are able to check how many trips someone did, but they are not able to link it back to the real person. So this is basically what we are talking about: sensitive data and how to handle the sensitive data. What companies want to do is they want to store all the data, but what they shouldn't do or they cannot do with all the GDPR rules is showcasing too much information to the people that shouldn't have information. So a lot of what you should think about your usage of data is not only how to store it once, but also how to share it across various departments of your company, making the information useful for them. So, for example, I'm giving to the business analyst all the list of trips by user ID, but at the same time, minimizing the data exposure, and in particular, the exposure of information that are not relevant for the analysis that this person has to do. So, for example, knowing my name or my surname or where I live is not relevant to, for example, calculate the average number of trips within my company. So this is where knowing what questions, it's again, going back to the idea that we had before about knowing the usage of your data, knowing the questions that you or your colleagues will ask about your data will allow you to basically define procedures or define little details in your data store that will allow to expose all the data to the correct stakeholders, but also to minimize the amount of, or nullify the amount of PII data, what is called personally identifiable information data, that you expose to them. So what you want is everybody in the company should be able to do their work. Nobody in the company should be able to see more data than what is necessary, strictly necessary, to perform their work.
Like how you gave the company example as well, and yeah, definitely there's like obvious data sensitivity, like okay, credit card information, yeah, that's sensitive data, but also like sometimes personal stuff that may not be relevant to everyone, but that can also be classified as sensitive data. All right, so we are coming out to the last question, which is obviously pretty obvious, the volume of data. So
Mm-hmm.
how much of a chunk of data you have and what you're doing with it. How does that affect the you know tool selection? And maybe you can also share, since let's say from your vast experience, what are some of the challenges that come with handling a really large amount of data? How do companies do that? Because small amount of data, it's fine. We make projects and stuff as hobbies, and so that's fine. But when it grows to an exponential size, what are some of the challenges that arise, and how do you solve those challenges?
Yeah, absolutely. So, as you said, if we have small data, yourself writing by hand on a CSV file, it's all you need, really. Or maybe, having a small database behind it, it will solve all the issues. However, when the amount of data grows, then it also become the challenges. Let me do a prefix here. With the current raise of computer specs and server specs, you can go really far with a lot of technologies. So, you can use single node databases like Postgres, for example, or MySQL to handle terabyte and terabyte of data if needed on a single node. However, there are challenges because when you think about huge volumes of data, when you think about not only huge volumes per se, but providing a service, a database service, a data storage service, which is affordable, which is highly available. So even if the primary node goes down, you have a replica that starts up immediately and stuff like this, becomes a little bit tricky on technologies that are single period, that are contained in a specific server. So most often, when you start reaching the threshold where storing or having one unique machine to take care of all the load becomes a struggle, you start using technologies that allow you to do more or less what is called sharding the data, to divide the data across multiple nodes. And there is a number of tools and technologies that allow you to do this for streaming services like Kafka, where clustering is out of the box. It's native solution. You can do that with extensions, also with relational databases like Postgres. The key thing here is, again, you like the volume of the data. It's the last question, but is also relevant as the other questions that we spoke before. The understanding what is the data volume, understanding how fast you want to ingest your data, how fast you want to process your data, is something that will tell you which technologies to use. Regarding the pains of handling huge volumes of data. So storing huge volumes of data can be problematic, not only because you have a high number of parallel writes to a database. Most databases can handle that perfectly. The problems most of the time, as said, is with other kind of workloads, because you write the data, but then maybe you want to analyze the data, and the query patterns of analyzing the data and writing the data are kind of different. So the impact on the database is kind of different. What you don't want to do is you don't want to penalize the writes, because the writes are your customers making orders on your website, because someone has to see the data in the dashboards. So what the state of the art of the technology is to use not only one technology, but a set of technologies to basically divide the data depending on where the data is. For example, you can do the sharding across. I want to store my Milan data in one database, my Paris data in another database, my US data in another database. But also kind of sharding the technologies for the intended usage. Let me give you an example. So let's say that we have a website and we want to have a database behind it that records all the orders. We have the website, we can put a relational database like Postgres that is optimal for this kind of transactional processes and allows you to achieve really high speed writes with a lot of data. But then, if we have the data in a Postgres database, we may want to analyze the data. As I said before, we want to analyze the data. without basically slowing down the writes from the website. What we can do is, for example, use a streaming service like Kafka that reads immediately all the changes happening in the tables in Postgres, and in streaming mode, so in near real-time mode, feeds an analytical database. In this scenario, what you're using, it's a mix of technologies, let's say Postgres for transactional, Kafka for streaming, and ClickHouse for analytics. And the mix of the three technology allow you on one side to achieve optimal performances on the transactional layer. So your application has optimal performances to write to the database. Kafka allows you to read from the database in streaming mode with adding really low complexity on top of what the database does normally. And then you have ClickHouse, the landing part, that is optimized for analytics. So you achieve the best performances across the three technologies without having impact on the source technology that is backing your application data or backing your application. So you achieve the best of the worlds. Most of the time nowadays, if you want to achieve the best performance across different access patterns, different layers, different use cases, there is no one unique gold technology that will solve all the problems. It's most of the time finding the right set of technologies that can work really well together in order to find the perfect solution.
Thanks for sharing, Francesco. I have one question. When we talk about this scale of data, let's say initially it just started out with like you have not that huge amount of data, let's say just a little bit, so you're working fine. But as the time goes by, the data is increasing, and let's say you're started with just your normal setup, whatever you're working with, just regular stuff. But imagine a scenario like, okay, you have that regular setup, but now you're expecting like the data is increasing quite a lot, and you didn't expect that. So how do you make that transition from not being used to handling a large amount of data uh, to handling a large amount of data? So maybe you can share, is there any like specific tool design for that, or what are some of the practices for this transition, or do you recommend just implementing these practices right from the start irrespective of the amount of data you have?
So I wouldn't say that so if you start a shop that is selling shoes now, and the shoes are homemade and your brand is unknown, I would not, never suggest to start with Postgres, Kafka, and ClickHouse immediately. It's over-engineering something, a business that you don't know if it will work or not. So my solution is kind of keep it simple. You start with Postgres because it has capabilities to store the data and it has amazing analytical functionality. When you start hitting the limits, this is a little plug about Aiven, for example. When you start hitting the limits of the Postgres instance that you created, with Aiven, we have amazing capabilities of creating a bigger cluster and with almost no downtime. So you can evolve your single node cluster and your infrastructure as much as possible. But at a certain point, you will hit the physics limit that even if you have the biggest single node computer, well, at a certain point, you will reach the point where your analytics queries will drain a little bit the performance on the transactional side. At that time, my experience says that it's not, again, all or nothing. You start by assessing what are the capabilities of Postgres. Postgres, for example, has an amazing capability of having a primary node and what is called a read-only replica. A read-only replica is a replica of the same data that you have in the primary node, but it's read-only, so it's designed to query it. So you can query the data without impacting the source system. And if you start moving all your analytical query on the read-only replica, you achieve already a better scalability. And then even if that is not enough, you start looking for new tools. But it's not a day one thing. It's a day 100, a day 200, depending on your business. The important thing is that you keep everything observed and monitored, because understanding the impact of adding a new set of shoes to your website and seeing the traffic increasing 20%, or there is Black Friday arriving in a month, I need to prepare my service, or I need to rethink my design because I'm already at 80% of usage of the disk or the CPU, is all stuff that you will know, you will understand, you will prepare for only if you measure how your system is behaving now.
Nice, because that's one of the questions I had around, like, do you started from this very beginning, or do you transition later on? Thanks for sharing, Francisco. And that was it. Those were the 5 questions. Learned a lot. I really like this format. Like five questions to ask yourselves. It's good CFP talk. You submit it somewhere. That's right.
Yeah, absolutely.
All right. Thanks a lot for sharing. And my last question is, can you maybe share if there are any emerging trends or something that folks should keep in mind, or any other resources you'd like to share? By the way, I'll leave all the links in the description below for folks to check it out. But yeah.
Yeah, I believe an emerging trend since kind of few years is this kind of streaming pattern where you want to make your data flow across the company in near real-time mode. A tool that has gained a lot of traction in the previous years was Apache Kafka, that allow you to basically take the data from one producer or one or more producers to one or more consumers in streaming mode. Something that is getting traction in the recent years is a project called Apache Flink. What Apache Flink does is basically kind of similar to Apache Kafka, but adds the capability of transforming the data on the fly. So with Kafka, you have the data more or less, the same data that goes in more or less goes out to one or more consumers. With Flink, what you can reshape, you can aggregate, you can mask the data, all the things that we talk about security, privacy, all these things are doable with Apache Flink. So I would suggest to keep an eye on both the old solid technologies like Postgres, like MySQL, like Cassandra, if you want to be in the NoSQL space, but also on the new trends like Kafka for streaming, Flink for streaming, because there is a lot of innovation happening there, and a lot of companies, especially when we talk about evolution from little system to big system, start using the streaming tools to basically glue a lot of data services together.
Amazing, and thanks for sharing, Francesco. And I'll leave all the links in the description below. It's great talking to you, and do check out Aiven as well. And they have some nice blogs that I'll also leave in the description. And I'll see you in the next one. Have a great day.
Thank you very much for having me. Bye, Kunal. Bye, everyone.